Hello, good morning, everyone. My name is Nicholas Bale, and today we are very happy with my colleague Tom to be with you this morning for this webinar. The title of this webinar is TKG and NSX ALB, known as the Avi Network Solution. Let's wait 1 minute just to give enough time to join, and we will start this webinar. Let's just wait 1 minute. Thank you. So once again, welcome everyone for this webinar this morning. My name is Nicholas Bale. I'm technical evangelist with the Avi business unit inside the VMware. And today we have this webinar called TKG and NSX ALB. So few things before we start this webinar. This webinar will start for about an hour. And this webinar is recorded, and at the end of the webinar, we will get the slide deck, so don't worry if you have anything you missed. You can always check the recording, and you can check also on the slides. During the webinar, if you have any questions, you have a Q&A window, as you can see, and you can use this Q&A window just to ask your question, and myself or Tom will make our best to give you some answers. So having said that, it's 2 minutes past the hour, so let's get started. And the first part will be presented by my colleague, Tom. Tom, over to you.
Yeah, thank you. So here's the agenda. It's actually pretty short. I will do a short introduction to TKG, so you get the setup. Then I will present how NSX Advanced Load Balancer or Avi is integrated with TKG. It's a little bit different than using the Helm chart, so I will go into all the details. Then we will go over the layer 7 options because there are many of them, but there is one preferred, as you will see. And
sorry, Tom, I'm not sure I...
Can you hear me? Can you still hear me? Maybe we lost Nicola. I'll just continue because I see my voice. Nicola, are you back?
Yes.
Okay. So then I will go into all the layer 7 Ingress options with one preferred, as you will see, and Nicola will do a demo in the second half. So let's start. What is TKG? As you know, VMware has some Kubernetes.
I think, Tom, we still have the same issue. I see one comment on the Q&A saying that, of course, we can hear, but we can't see anything. I can see your mouse, but I can't see the deck.
Interesting.
Now I can see it. But I think when you go on to presenter mode, it goes away and we see this white page only.
Okay, then let's do that. I mean, it should be big enough, right?
Yeah, hopefully. It is big enough. Yeah, no problem.
It worked before. So yeah, sorry for that. So we have VMware Tanzu and TKG, and both are using cluster API. I mean, that's the mechanism VMware was or is standardizing on. It's basically using Kubernetes to create Kubernetes clusters. And you see here how it's done, right? I mean, Kubernetes, you have all these custom resources like a pod, a replica set, deployment, and that's the way Kubernetes is doing things. It's not starting from the top, it's starting from the bottom and just building up more and more features. Like a pod is just creating something, replica set is making sure that you have multiples of them, and the deployment can do lifecycle management. So with cluster API, it's exactly the same. You have something like a machine. A machine set makes ensure you have multiple machines and they're always there. Machine deployment does the lifecycle management. Then you have a concept of a cluster and the control plane, which are the management node. That's how it's working. The question is, of course, how do you get this initial Kubernetes cluster? With VMware Tanzu, you have the supervisor cluster there, and you install it, and then you can just use it. With TKG, you have this bootstrap cluster, which is created by the Tanzu CLI on your local system. Could be a Linux system, a Mac OS system, or Windows system. Right now you need Docker because the bootstrap cluster is using kind, which is Kubernetes in Docker, which is meaning we are spinning up containers and inside them we are running Kubernetes. So as I said, the Tanzu CLI is creating this bootstrap cluster and then using the cluster API to spin up a management cluster. The management cluster could be on vSphere. It could also just talk to the supervisor cluster, or it could be on AWS or Azure right now. So we then spin up this management cluster, and you can do that with this command, which basically starts a UI, and you can configure it. And when this has been finished, we transfer the information how this has been created, because we still need it, right, to talk to the infrastructure provider. And then you can go on and create multiple workload clusters. And the difference of TKG and VMware Tanzu is actually that you can create many management clusters, and you can create them in, as I said, in different cloud environments. One thing you have to know, that when you want to create a cluster, you need a configuration file. The first one, you can create it with the UI. The second one, though, you have to do it somehow, right? And what I normally do is taking the one I created for the management cluster and changing maybe the name and some other variables. And that's what you will see on the next slide. So this is how, for example, you configure Avi in this UI I was just talking about when you start the creation of the management cluster. So you go through this interface. I will not explain all the properties here because I will do that later on. But you see, I mean, of course, you should know NSX global answer. You have the default cloud. You can choose another cloud. You have a service engine group, and you have 2 VIP ranges. As I said, I will explain that later on in more detail. It's just to show you how this works from a TKG perspective. In the background, for the manager cluster, we create a file, and this file basically just have a lot of properties set. And here you see what you see. For example, you can set for Avi. Don't worry at that point. I will explain the variables later on, but you see how to access it, username, password, certificate, and the default cloud, and maybe a service engine group, and then 2 VIP network ranges. If you want to know what kind of variables you could configure on top of what is available in the UI, you can go to this configuration default file. So it's under .config Tanzu TKG providers, and there's a file called config default YAML, and there you see everything you can actually configure. You might ask, why are we doing that, right? Because, as I said, we are creating a Kubernetes cluster using Kubernetes APIs. It's basically an extension of Kubernetes with custom resources. But doing that by hand is pretty overwhelming. There are a lot of things you have to set in the YAML files, and it's probably too complicated to do that. So what we are doing is basically using a templating mechanism which simplifies that, and then you just set some variables, and we create the cluster API YAML file for you in the background and create a cluster. In the future, there will be a little change because we also want to have an API to create clusters, and VMware Tanzu was using something called Kubernetes clusters, and we will use something called cluster class, which basically allows you to specify clusters in a much simpler way, but not using variables. It's still just Kubernetes. You create a YAML file and you create the clusters. You have also templating mechanism for different kind of clusters. So things are evolving, right? I mean, that's what I want to say here. So that was it about TKG. As I said, it's creating clusters using cluster API. Initially use the UI to create a configuration file. then you adapt that to create your workload clusters. The question is now, how is Avi integrated? And that's a little bit different than what you might know using a Helm chart. And that's what I will explain now. Let's look at the first of the whole architecture, all the components of NSX load balancer. I'm sure you know that, but still let's repeat that. So you have the controller or controller cluster. It's your single point of management for everything. And of course, you can program it, and that's what we are exactly doing with the AKOO integration. Kubernetes will then program Avi using this API. The service engines handle all the data plane operations. I mean, it's very scalable. You have all these analytics features you will see later on, and they are created automatically, and you don't have to care about that. You have full control over this using AKOO, and you will see how to do that with TKG. Then you have the Avi Kubernetes Operator. That's what you normally install by hand using a Helm chart. It runs as a pod, and it creates, it provides all this functionality, you know, I mean, layer 4 load balancing, Ingress, and translates basically the Kubernetes objects you specify in Kubernetes to controller APIs. But now comes the difference with TKG. We also have something called the AKOO operator that's running in the management cluster, and you basically configure everything when you create the management cluster. You will see that in a second also. And from then on, you don't have to install AKOO on the workload clusters anymore. The AKOO operator is doing that for you automatically. So you don't have to specify credentials anymore and things like that. And it's using kind of a default configuration. If you don't want to use them, you can change that later on using so-called AKOO deployment config, which I will show you later on. So that's how it looks like from an architectural point of view. You have the vCenter appliance, right? The Avi controller cluster is talking to that to create service engines. And when you create the manager cluster, you have the AKOO operator being installed, and it's installed as a TKG package. That's also something a little bit different. It's not a Helm chart. It's kind of a wrapper around it and doing all the lifecycle management, right? I mean, if you have a package, when you update the class, it's automatically updated. When you get a new version of Kubernetes, it's also updated, things like that. So you don't have to handle that anymore. It's fully automated. We also have one AKOO actually running on the management cluster. Technically, you don't need that, but in case you might want to create a service type load balancer layer 4 or things like that, you can do it on the management cluster. It's not best practice to install things here, but you can do it. And as I said, when you create a workload cluster, then this AKOO operator is now actually watching resources on the management cluster. Basically, oh, there is a new cluster being created. I need to install AKOO on it, and it will install AKOO on it using a default configuration. That's important. If you don't want that, you can actually say, no, don't install anything. I will label my clusters, and then you will get other configurations. I will see that a little bit later on. So just to repeat, right? I mean, the AKOO operator is deployed by the Tanzu CLI using this add-ons manager. That's a difference to when you do it manually with the Helm chart. And AKOO is deployed by the AKOO operator using this add-ons manager, right? And it's doing automatic upgrades. And you can also change settings real time by manipulating this AKOO deployment config. And you see it here on the command lines, right? I mean, first of all, you have packages. That's the name for add-ons. You can also use apps as a name, and show me in this namespace TKG system the AKOO operator which is running. Okay, that's good. Then in the Avi system, you have AKOO running. That's the AKOO on the manager cluster. And you have the AKOO operator, which is also running on the manager cluster. Okay, everything is good here. And you see both of the configurations we had using these Avi deployment config files. And you also have a resource called ADC, which is it's just an abbreviation of AKOO deployment config. And you see I have two of them. So this AKOO operator is installing one for the manager cluster, and is having another one for all the other clusters I'm creating. But as I said, you can install more of them, and we will actually do that later on, installing another one which adds some other features to the whole setup. So that's how the basic thing is working. As I said, initially we have some variables. Let's now take a closer look at that. And when you create a manager class, just look at this entries here. You say Avi enable, true. Okay, so you know you're not going to use another load balancer. I mean, we have some others like KubeVip, which is kind of a Kubernetes thing, but if you want to enable Avi, which you should do, set it to true. You can choose a cloud name. It does not have to be default cloud. You can create your own cloud, but it has to be a vSphere cloud, not an NSX cloud. And then you just say how to connect to the controller using the IP address or DNS name, and also specify default group. Okay, that's just basic things. If you now look at the picture on the right, you see there are two VIP networks to do load balancing. One is for the Kube API server for the control plane nodes. That's the red thing here on this picture. The blue one is for, let's say, service type load balancer, or for Ingress on the management and the workload clusters. And you see we only have two network ranges for the VIPs here. But we continue to make that even better. You will be able to separate all four of them in one of the next versions. I don't know exactly, the code is already in, but we're still hardening and debugging it, right, to make it enterprise ready. Right now, it's only have these two networks, so you can separate them. And you see it here. They are called control plane HA provider, which actually means, if I set it to true, use Avi to load balance the Kubernetes API server using this VIP network 1 and using this network range you see in the Avi controller. The second network is called VIP network 2, and you see it's not the same range. I'm just using another one. And when you create objects, or when TKG itself is creating IPs for the load balancing of the API server, it takes it from that range, right, or the other range. Yeah, the last thing is these labels. If you don't do any label, every cluster by default, the workload clusters will get the default configuration of Avi. If you set a label and you don't label your clusters using kubecontrol, label, cluster name, and then, for example, AKOO equals yes, this AKOO will then need to be installed on this cluster. If you don't do that, Avi is not installed. If you create another deployment config which is using another label, let's say node pod local, you will see what that means later. The AKOO operator sees that and reconfigures the AKOO on your workload classes automatically, because it could already have the default configuration, but you don't want to use it. You use another one by labeling the cluster, and then you get the other one automatically configured. This is an example, and we will see later on in the demo much more how to use that. It's just using standard Kubernetes, so you have a deployment using an Nginx container here, and a service of type load balancer. You see here type load balancer, and when you do apply this YAML to your Kubernetes cluster, you basically get a load balanced web server using two replicas. I specified the load balancer IP. You can do that if you want, so you exactly get the IP you specified when you do a kubecontrol get service. If you don't specify, AKOO will just take one of the network range you configured before using this network here, the blue network. And having done that, you see everything in the controller UI. Okay, I have a service type load balancer, and I have two things which are low balanced here, right? I mean, you will see that I will explain a little bit more about that, what that actually means. You get some logs here and some more analytics for layer 7 when you create an ingress. And you see here that I was doing the same game. I'm creating a deployment, then a service of type cluster IP. So it's not type load balancer here. And I have an ingress, which is specifying DNS name. And you can access this application under cafe TKG Tanzu/T. The thing is here, I specify this ingress class name because TKG is not setting Avi by default. You could have another one, and you really have to be specific. If you use the Helm chart, you probably have set it as default, and you don't have to specify that. That's important. With TKG, you really have to do that. And the nice thing, because I use DNS delegation from my DNS server to the Avi DNS server, so all these DNS names are actually created automatically. You don't need any wildcard DNS name, which is a huge advantage, because I know many customers just don't like that to use wildcard DNS names. Then you see all the analytics, which you also will see later, and I have some troubleshooting commands you can actually execute. That's just for your reference. I mean, most of them I already showed. I mean, you see in the corresponding namespaces, you see what's going on. If the pod is working, you can get the logs of your AKOO. In case it should not work, maybe you have a wrong password or the certificate is not correct, things like that. With this version, you also had to create your own cert for the Avi controller, because you need not only the IP address in the subject alternate name fields, you also need a DNS name. That's something you have to do, otherwise it's not going to work. So it's good to have the logs here. Now the next part, before we go to the demo, all the ingress options, you have many of them, and the one you should use is called node port local. The other ones, you will see the downside of them, right? Using just node port or cluster IP, which is certainly the second best choice, or if you don't use Avi for layer 7, you can also use Contour. So what's the difference? Cluster IP actually is okay, right? It leverages the full ingress capabilities. It does direct routing to the pods, but it's using a mechanism because basically AKOO is telling the controller, oh, we need some routing information. That's actually configured on the Avi service engine. So when we come from the outside and we need to reach the pod, which of course is natted, right, with Kubernetes, so you cannot really reach them. We need a route there, and the Avi SE knows to reach a pod, you actually go through this IP address of the node, and then you can reach the pod. So that's what is configured. The downside of it, each Kubernetes cluster requires a dedicated service engine groups, and you will have many of them if you need many more clusters, right? I mean, that's a downside, but from a technical perspective, it's absolutely fine. What you then see, right? I mean, you see the endpoint here of this web service here, and it's a natted IP address, so you can actually not reach it from the outside. And that's the magic which is done through this routing information on the service engines. Node port is configured by default on TKG. That's why I will show you later or in a minute how to change that. What happens here, we can just talk to the IP addresses of the nodes or the certain ports, and behind that we have kubeproxy actually doing the load balancing. So you basically have a double load balancing. And you see the problem, you could actually be load balanced to a node and a certain port where there is no pod running. So kubeproxy is actually redirecting the traffic to the right node. And it's even worse, as you see on the next picture here, because you will have also the IP addresses of the control plane node, of the management nodes, and most of the time you're not running pods on these nodes, but you will still see them. So you go to the IP address, you're redirected to maybe a management node, and the management node, okay, doesn't have a pod, so kubeproxy is redirecting to another node where you have the pod running. So that's what node pod is doing. And node pod local, which is something specific to TKG, or basically when you have Andrea installed, that's the requirement you need, because it's something we do with Andrea. So what happens here when you set Andrea node port local, that's a configuration option you have to set when you create your workload clusters. It really sees the pods directly. But as I said, there is some magic going on using Andrea, the container network interface. And you see that this is working when you get node ports which are above 60,000, 61,000. So if you have port numbers which are maybe 30,000, you know it's node port. If you have port numbers which are above 61,000, you know, okay, node port local is actually running. And yeah, you also see we do that by some annotations in Andrea and do some magic to make that work. But it's only working with Andrea right now. Our own, I mean, the open source container network interface we submitted to the Cloud Native Computing Foundation. So it's now a project of that foundation. But I mean, we use it a lot and drive the features and do things like that. So how do you configure that? As I said, you need to do the cluster configuration, but you also need another AKOO deployment config. And the only thing you do, you add a few things. Maybe the first question, how you get that file? I mean, you can of course copy it from the documentation, but what I normally do is just do an export of the default configuration, doing a kubectl get adc install AKOO for all -o YAML, and then redirect it to a file, and then just change these properties here. So as you see, I actually add a new label, because now I need to label my clusters with this npl true label. And you see here what I configured. Basically, I have a service type node port local. I give it the network range, and disable ingress class is set to false. So you deploy that on your cluster. You create the cluster using Andrea node port local, and then the AKOO operator is seeing that, oh, this cluster actually is labeled now. I have to reconfigure it using this AKOO deployment config, and you will get the node port local. That's how it's done. And here you see the difference. I mean, that's huge, right? Here I have the node port configuration. And this node is, as I said, is a management node, and these are workload nodes. But Avi just sees these 3 endpoints, and he does not see the 5 replicas in each deployment. With node port local, you see all of them, and you see the port numbers, 61,000, and so on. And you also see the difference. I only have 2 of them, and the management node is not there because it's not used. So we are not load balancing to something, to an endpoint, which is actually not there. We really see all the endpoints. And Nicola will show you when you actually scale up the deployment, you will almost immediately see that some more are added. Here we'll see nothing because we just have 3 nodes, and that's it. You can have 100 pods. You still only will see 3 of them here. With node port local, you see all of them. So exactly 1/2 an hour as I was planning. So Nicola, take over now to do the demo and show all the good features I just tried to explain.
Can you hear me?
Yes.
Nice. So if you can have a look on the Q&A, because we have many questions. I have responded some of them, but not all of them. So if you can double check, Tom, there is a QA window, and you can see all the questions. And to be honest with you, we have received quite a lot of questions on the licenses. Can I do this with Essentials? Do I need the enterprise license to see the analytics and question like this? Just to clarify, here during the demonstration, I am using the enterprise license, so I get the full capability of the product. If you don't have the enterprise license, at least you cannot use the product for GSLB, for advanced security features, and you get a limited capabilities for analytics as well. So let me share my screen first. Share screen. Okay. I need to make myself presenter. Okay. So can you see the slide, Tom?
Yes, yes, I can.
Good. So let's see this in action. So far what we have reviewed with Tom is how basically you can do the initial configuration. So you don't expect your application team to do that. What Tom has described basically is going to be handled by an admin of your Kubernetes cluster. Is going to be handled by someone else, not someone from the application team. But at the end of the day, what you will get is what you can see here on the picture. So you have deployed your Tanzu cluster. So you have at least one cluster, as you can see here in the screen. And within this cluster, what do you have? You have AKOO, the Avi Kubernetes Operator, up and running. So as Tom described, it's just a single pod. And this pod will basically do the API translation calls between what we have in Kubernetes, and it will send those API calls to the Avi controller. So this is, in a nutshell, the goal or the reason for leaving of this Avi Kubernetes operator. And the intent here is to make sure that now, since you have done the initial configuration, each single features of Avi can be consumed by the application team. And to do that, the application team will just need to leverage Kubernetes API calls. And then the AKOO will see those calls and it will configure everything on the Avi controller side. And then after, you know that the Avi controller side is just an orchestrator. So the Avi controller will orchestrate the life cycle of the service engines. So as you can see in the picture, the Avi controller will then after deploy service engines outside of the Kubernetes cluster. So load balancing will be achieved by virtual machines, which we call service engines. And those service engines, again, they live outside the Kubernetes cluster. And from the service engines, the packet will arrive, and those service engines will load balance directly the pods to make sure that your Kubernetes application is reachable outside the Kubernetes cluster. So here we are talking about north-south load balancing. Here we are talking about how to secure your application, because you know that all the load balancers now, they are providing security features to secure your load balancer, like web application firewall, for instance. And what we are talking about is also how we can scale. Because if you are thinking of legacy load balancers, those legacy load balancers, they are using active standby algorithm or HMOD to load balance. So it's a pity because you have your application running in Kubernetes, and because of the nature of Kubernetes, you can easily scale your application, but your load balancer outside of your Kubernetes cluster, you cannot scale them. So one thing that I want to demonstrate here is how you can scale your application and how you can scale your load balancers to make sure at the end you have something which is very elastic. The second point that I will demonstrate is related to analytics. This architecture is not easy. When something goes wrong, you need to make sure you have some data points to troubleshoot efficiently your application. So this is something else that I will show you. And the last thing that I will demonstrate is about security. So how I can leverage the same solution to secure my application. So having said that, before demonstrating this, I would like to just show you the detail of my setup here. So let me just log in here. Okay, so I have 3 windows open. This is one of my Avi controller, and I will log in. And I have also my Kubernetes cluster here. So let me just make this Windows clean. And here I will connect to one of my clients from where basically I can make sure my application work, right? So I will just use this command here, and I should be connected to my client. So here I have my client, here I have my master node, and here I have my Avi controller. So what I will do here first, I will show you that AKOO has been installed already. So first thing, I will just display all the pods that I have on my Kubernetes cluster. And you will see that AKOO is running. So my initial configuration, all the stuff that Tom has described, it's already done. One thing that is very good to check is just the log of AKOO, just to make sure there is no issue with this pod. So you can just leverage the kubectl logs command. And from here, you can display basically if there is an error or if there is something wrong with your AKOO pod. And right now it seems to be okay. So nothing to worry about. I can just exit this. And what I want to show you first is that all the things that I will do, any application team knowing Kubernetes can do exactly the same, because we are not leveraging some special features or special API call of Avi. We are just using the standard Kubernetes API call. So the first thing that I want to do is, first of all, I want to check my services. So if I check my services like this, with this kube control get services, I see that I have nothing. I just have one, which is used by Kubernetes itself. So what I will do here, I will create a service type or service type cluster API. So I will just create this by using this command here. And I will show you this YAML file. So very easy, basically. What I'm doing here, I have this kind, which is service. And by default, this is a cluster API, the type. And I'm saying basically I have an app selector. So all the pods which match the label web front one, basically, will belong to this service cluster IP, right? So very easy. And I just want to make sure that this has been created properly. Let me just check this. That's this one, that one here. So as you can see here, I have my web front one service, which is up and running. So now something that I want to create is an ingress, because I want to expose my application outside of my Kubernetes cluster. So to do that, again, first I will check that I don't have any ingress configured. And I will apply a new ingress here. I will also show you this YAML manifest just to show you that there is absolutely nothing complicated here. So it's an ingress here, and you define a host, basically. The host is ingress.cluster1.avi.com, and you define a path. You can see here, I can have one path, but I can have multiple paths. And what I'm saying here is a slash here will be redirected to a service, which is web front one. So you see that this service here has been defined basically just here. So there is a link between this ingress and this service for the path slash, right? So this ingress has been created. So if I go back to my Avi controller, as you can see already, I have 2 virtual services. Before, I had only 1 virtual services. Let me just clean up some stuff here just to make sure I have enough space to show you more. And as you can see here, this ingress here has been configured just here. And I can even show you more, but what I want to show at this point here, it's how it works for the data plane. Because now you saw exactly what AKOO can do. It just intercepts the Kubernetes call and sends those Kubernetes calls to the Avi controller. And the Avi controller actually managed to create a service engine. So this was very fast. So the service engines were created before. That's why it was very fast. But sometimes here it will take you a few minutes to make sure that your virtual service is up and running, right? So as you can see, my virtual service is up and running. If you go to the dashboard here, you have a great view of your configuration by checking the tree view here. And from here, you can see all the topology. And as you can see here, there is something wrong here. It says no servers available within the pool. And there is a reason for that. It's because I didn't create my deployment, my application. So this is what I will do right now. I will create my application just by creating a deployment within the Kubernetes cluster. Okay. And then I will make sure that this deployment is ready. As you can see, I have my deployment called WebFront1, and I have 2 pods. So I expect at some point here, if I just refresh this, I should see at some point something green here. So let's wait a few seconds just to refresh everything. And as you can see, 1 pod is ready, and now everything should be up and running. So this is, let's say, the control plane thing, right? Because again, I did nothing, and Avi, thanks to the AKOO, the Avi Kubernetes Operator, and thanks to the Avi controller, orchestrate everything for you. So how does it work? Now for the data plane. Well, if I go back to my slide deck here, just checking this slide, what happens first is your client, which is here, can definitely use outside of your Kubernetes cluster this application, but it needs to know an FQDN. And as Tom explained at the beginning of this session, we have the capability to automatically register FQDN for your new Kubernetes application. How do we do that? Well, actually, what we are doing is AKOO, you will define in your YAML file a host or FQDN for your new Ingress. You remember the ones that you have defined? It was on the YAML manifest. And then basically AKOO will send this information to the Avi controller, and your Avi controller here can basically configure a DNS. It could be a DNS virtual service, which your Avi controller has configured, or it could be a third-party DNS solution. In Avi, we have something called the DNS profile, and the DNS profile tells the Avi controller, oh, by the way, I have a new virtual service. For this new virtual service, you need to configure a DNS entry. And again, this DNS entry can be configured within Avi itself in an Avi VS, or it can be configured in a third-party solution. If you guys, you are running Infoblox or something similar, we can definitely integrate with such third-party solution. So this is how the DNS registration will work. What did I use in my setup here? Going back here, actually, you will see that here I have a DNS virtual service. Going back to this view here, you will see the IP of this DNS. So this is a virtual service, and the type, as you can see here, is listening on port TCP or UDP 53 because it's a DNS virtual service. So you see the IP is .100 at the end. If I go to my client here, and if I make sure I check what is this, the DNS server IP, which has been configured here, you see the IP is the same. This is this Avi VS here. So what I expect here is, without doing nothing, I should be able to ping the FQDN of my Ingress here. So this is the IP here. And sometimes it takes a few seconds. So let me just do 2-3 attempts here, just to make sure it works. It takes times, I noticed, but here it is. So now I can automatically resolve this, the IP of my Ingress, my FQDN here, and you see the IP is .102. So if I go back to the Avi controller VS, this is the IP of my virtual service, which is acting as an ingress for my Kubernetes controller. So I hope this DNS registration makes sense. Again, we can do that leveraging the Avi DNS virtual service, or we can do that by leveraging a third-party solution like Infoblox or any other solution. The only prerequisite is to make sure that you have a REST API because we can, in this case, integrate with such REST API of your DNS solution. All right, so this is the first step. And now we have done that, what I want to check is my application working? So basically, from my client here, I can just curl my application using the FQDN. And here it is, a very basic and ugly application, but it works. I can curl my ingress.cluster1.avi.com, and I can see the result here. So this is the first thing that I wanted to demonstrate. And basically here, what I have demonstrated is just what you can see here. First, DNS request to a virtual service or to an external DNS server. And then you will request, you will send the request to the VIP. And then the service engine, they will send this request to the pod directly. And I believe Tom explained already how the service engine can reach directly the pod. We have many mechanisms to do that. The one that I am using right now is not port local. I think Tom explained this already, but just to show you this live, if I go back to my UI here, you will see, going back to the dashboard, this is very convenient, this view. You can see that behind my virtual service, I have a pool, and behind my pool, I have those pool members or application server instances. And as you can see here, this IP .201 and .202, this is somehow the IP of the nodes of my Kubernetes cluster. I'm using not port local here, and this TCP port here will basically redirect the traffic to a specific pod within this node here. So this is not port local. And just to show you that, if I just go back here and I type kubectl get nodes -o here, wide, you should see the IP here of each nodes, and you see 201 and 202. This is exactly the IP that you can see here, right? So this is, in a nutshell, how it works. And again, here, I'm not trying to explain you all the details. I'm just trying to explain you that any members of an application team can use this without knowing Avi itself. All right, let's go back to the slide. And let me show you here something else, which is elasticity. So elasticity here, what I want to show you first is that we can automatically update the pool members if at some point you decide to scale your application. So let's see this in action. So going back to my beautiful UI here, as you can see, what do I have? I have 2 pool members. And at some point here, I can decide basically I want to scale my application just to make sure I have 6 pods instead of 2. So going back to my Kubernetes cluster master node here, I just type this command, and I'm saying basically I want 6 pods. So Kubernetes will scale out the amount of pod, and I can double check this here. As you can see, now I have 6 pods for this specific deployment. And you expect what? Just as you can see here, now I have 6 pods as pool members of this specific virtual service. So of course, we do that fully automatically. You can witness what I have done, nothing, just a Kubernetes API call. If I refresh this, I should be able to show you something better, right? But now you think that's good, but I have only one service engine to do the load balancing, as you can see here. So what is the option that I can have if I want to scale out the amount of service engine for this application? Well, it's very easy to do that. If you want to do that, you just need to click on your virtual service here. If you click on the virtual service here, you have this scale out button. And you may think that's good, but that's manual. And don't worry, we can do that manually or we can do that automatically. We can do that automatically because in Avi, you have a lot of analytics. So basically, we measure a lot of data points like the CPU of the service engine, the memory of the service engine, the PPS of the service engine. So by triggering some threshold, we can say, hey, I want to scale out, and we can do that automatically. So what I will do here, I will just do that manually, just because it's more visual, but again, you can do that automatically. So if I scale out, now it says creating a service engine. So basically what the Avi controller is doing is deploying a new virtual machine, which we called service engine in vCenter in this use case. And this guy here, at some point, you see, I have two service engines here. So just ignore the error. I'm not sure what it was, but the most important thing, as you can see, I have two service engines. If I go back to my dashboard view, which I like, you will see that now we have two guys here. And this is very good because we are running active here. We are not active standby. So you can understand how elastic is this solution. All right, so that was about elasticity. I want to show you a little bit more about visibility. So again, here I am using an enterprise license. So I get the full feature set regarding analytics and observability. So let me go back to the UI, and I just want to show you very quickly what we can do here. So I will use another setup here just to make sure we have more information, because the other setup, I just created it this morning and we don't have a lot of data points. So if you click on the virtual service here, always remember that what we are showing is a good observability data for your application. And the first thing that we show by default is this end-to-end timing. As you can see, this is very important, because if your application is slow, what will happen? People will get something else, they will go to the competition, they will complain, and you need to make sure that you have all the data points to troubleshoot your application. So as you can see here, we have the end-to-end timing, which is made of the client RTT, the server RTT, and the application response time, data transfer, and then you have the total time, which is the sum of those times, right? And basically from here, it's very easy to troubleshoot. If you see here from this morning, 10 a.m., I have a peak of latency. The green one, the client RTT, is quite stable. But as you can see, the orange one and the purple one here, they have increased since 10 a.m. this morning. So I know that there is an issue for the application response time and the data transfer. So it's something between the load balancers and the application server instances. So if I want to troubleshoot further, it's very easy. You go to the logs here, and on the logs here, you can see the non-significant logs or the significant logs. Significance, it's like Avi thinks that there is an issue for this request. And all the requests, as you can see, they are here. So if you want to see, let's say for my application response time, I want to do a filter higher than 100 milliseconds here. Oops, sorry, let me just clean that. You will see that very easily we are showing all the bad logs that have started from 10 a.m. this morning, as I mentioned. And if you want to understand more, you have some advanced, or I would say, other filters that you can leverage here on the right-hand side, and just showing this, I can identify which server IP was slow to answer. As you can see, this is this .202, which was very slow to answer. So very easily, I can leverage this analytics to troubleshoot faster my application, avoiding this finger-pointing story between the network team and the application team, where it never ends, and at the end of the day, your company is the one liable for this issue. So this is very useful to have this analytics. I don't have a lot of time here, but I want to show you that for each single request that we are doing to your application, Avi can record everything. And this everything includes a lot of parameters, a lot of details for the client, a lot of details for the service engines or the load balancer, and a lot of details for the server response. This is very critical to have all those information, again, to automate Avi, and more importantly, to have an efficient troubleshooting. All right, so let's continue and let's finish this demonstration by talking about security. Oops, sorry. All right, so now we have created an ingress, right? You remember I have my application running, but I want to make sure that this ingress is secured. So right now I have created an ingress, but it does not leverage HTTPS. It does just use HTTP. So what I will do, I will come back to my UI here, and I will show you that. As you can see here, I just do a basic curl without leveraging HTTPS or TLS. So what I will do here, I will just somehow upgrade this ingress to make sure that this guy is using TLS. So to do that, I will just apply this specific CRD that we are leveraging here. And oops, wrong window. This is this window here. And I will just show you the YAML file. So basically here, I'm saying basically, I want to define this host rule. And basically for this FQDN, which is the FQDN of the ingress that I have configured, I want to use an SSL key certificate, which has for name this one here. So this certificate has already been installed in the Avi controller. So now if I go back to my client here and I try to curl, what will happen? Well, it fails. And as you can see here, the HTTP here response code is 302, which is an HTTP redirect. So I expect that if instead I am using a curl -k HTTPS, this should help. So what I will do, I will just use this command here, which is just a while true loop. And as you can see here, I am using a curl -k just to ignore that this is a self-signed certificate on this specific URL, same as this one, but I am using HTTPS here. And I expect that now I can use my application leveraging HTTPS between the client and the service engine. And I still have clear HTTP between the service engine and the pods, right? So it gives you an idea how you can leverage this from an application developer perspective by securing your application by using TLS. Now I want to show you something else. Let's imagine that you have certificate which has been installed within your Kubernetes cluster. So as you can see here, I have secrets that I am using in my Kubernetes cluster. And one of the secrets here is called cert01. And you can see that the type is TLS. So the question is, can I use this certificate if I create a new ingress just to make sure that certificate can be also managed by Kubernetes? Well, as you guess, the answer is yes. What I will do here, I will create this new ingress. And just before typing enter here, I will just show you the amount of virtual service that I have. as you can see, 3 virtual services. Then I go back to my Kubernetes master node. I apply this new Ingress. And as you expect here, I should get 4 now. So I have this new Ingress, which has been created. And as you can see, there it's called secureingress.cluster1.avi.com. And if you check here on this guy, there is actually, you see this SSL certificate, this has been directly imported from the Kubernetes cluster. So this is kind of cool because you can leverage TLS certificate within the Avi controller, or if you don't like it, you can leverage TLS certificate from your Kubernetes cluster. And as you can see here, I should be able to use my application by using this new FQDN because, again, new Ingress has been configured, and therefore a new FQDN has been created. As you can see, I can curl this new Ingress FQDN, right? And the last part that I want to show you is likely you want to secure your application by using web application firewall. So let's assume that your application is a web application. You want to secure it. How you can use Avi to, on the top of this, apply web application firewall rules. Well, to do that, you can just leverage, again, some CRD that we have here. So you go back to your Kubernetes master node, and from here, I can just apply this specific CRD, and I will show you that in a sec. Well, as you can see here, I have a specific CRD related to AKOO, as you can see here. And I'm saying basically for this FQDN, the ones that I have created just before, I want to apply this system WAF policy. Going to the UI here, at some point, as you can see, there is a shield here telling you that I have my WAF policy applied. So very easily here, I have demonstrated that once you have done the initial configuration that you can do with all the tooling that Tom explained, very easily you can leverage the Avi capabilities or Avi feature set by using the Kubernetes API. You can definitely do elasticity. Everything is fully automated. You can do visibility. And more importantly, you can do security by enabling your virtual service with TLS and web application firewall. So having said that, it concludes my demonstration. Before closing this call, probably Tom, let me know if we have still many questions to answer or if we are pretty good. And if you have any questions, this is probably the right time to raise it.
Yeah, I was pretty busy answering questions. I have two which I would like to double check with you because I'm not sure 100% which operating system we are using for the service engines. Do you know that?
I think it's right now, I think it's still based on Ubuntu, but probably it will change soon. But I don't know what is the goal of this question. I'm thinking about probably I have two thoughts. First one is about security. If this question is related to security, just you can contact your VMware sales representative and ask for a pen test that we are doing towards the solution, just to make sure that the Avi solution and especially service engines, they are safe. If it's just for your knowledge, again, this is based on Ubuntu, but as far as I know, this will change in the next few months.
Yeah, this was also my answer. Yeah, right. This was also my guess. And the second question, I would like to double check with you how to set up static route on Avi Essentials using multiple web networks. Do we need to add multiple default routes or a single route to backend servers?
To backend servers. So I'm not sure if this question is in the context of virtual machines or if it's in the context of Kubernetes pods. I'm not sure. So just I can show you where you can add some routes in Avi. It's quite easy. You go under infrastructure, and under infrastructure, you have cloud resources. So if you have more than one cloud, just make sure that you select the proper cloud here. So in this case here, it relies on vCenter. So I will select my DC1 vCenter. And from here, you can add some static routes. And it's very easy. You just here mention the IP of the route and the next stop, like the subnet, and you are good to go. But it's difficult to answer this question not knowing the overall context, but this is how you can add a route.
Yeah, so the rest I answered. As I said, I think we can close the session then.
All right, so I just want to share some next steps before closing the session. So if you need any information, especially about the licenses or other stuff, just contact your VMware sales representative. If you have questions about this webinar or even feedback, positive or negative, don't hesitate. You send an email to learnavi@vmware.com. Again, learnavi@vmware.com. We have some 4 days workshop, which are free of charge. So if you want to join us and to hear about all the feature set of Avi, you are welcome to register. If you want to play with Avi, you can always go to VMware Hands-on Labs. We have some very good hands-on labs about Avi, and I'm sure we have similars for TKG. And you can also download and install your Avi in your own environment. You go to customerconnect.vmware.com. The Avi documentation, you have the link at the bottom of this slide. So having said that, I really want to thank you, Tom, for your help for this webinar, because it was very useful to hear all your knowledge about how to configure the initial configuration on TKG. So thank you very much, and thank you everyone for your time.
Bye-bye.
Thanks, everyone. Have a good day, and you will get a copy of the recording later. Thank you, everyone. Have a good day. Bye.